A cylindrical bar magnet, 10 inches in length and 1 inch in diameter, has a magnetic moment of 10,000 ergs per erstat. What is its magnetic moment in SI units? Okay, so I want to elaborate on this unit for the magnetic moment in CGS. We can see that this unit comes from the energy of a magnetic dipole moment in a magnetic field. So the energy is minus m dot product with h, where m will be now in units of ergs per erstat. Okay, so this comes from this equation. So this is a CGS equation, and CGS unit for m, ergs per erstat, is what we call electromagnetic unit, EMU. And we know the following for the conversion between CGS and SI. We know that for magnetization, we have the following conversion. For magnetization, 1 EMU per centimeter cube is equal to 1000 ampere per meter. So if I multiply both sides with 1 centimeter cube, this is to find the conversion between magnetic moments in SI and CGS. 1 centimeter cube is 10 to minus 6 meter cube. So we will find that 1 EMU is equal to 1000 times ampere per meter times 10 to minus 6 ampere per meter and meter cube. So this will give me 10 to minus 3 ampere meter square. So that's the conversion. So if I have a magnetic moment of 10,000 EMU, this is equivalent to 10,000 times 10 to minus 3, which is 10 ampere meter square in SI units. So this is how I convert it to SI. What is the magnetization in both CGS and SI? So that's part B of the problem. So for magnetization, I need to know the volume of the cylindrical bar magnet. Now the length is 10 inches. So 10 inches is equivalent to 10 times 2.54, 25.4 centimeters, or 0.254 meters, because it's 10 to minus 2. The diameter D is 1 inch. That is equivalent to 2.54 centimeters, which is 0.0254 meters. So this means the radius, which is diameter divided by 2, is 1.27 centimeters, or 1.27 10 to minus 2 meters. Okay, so the volume V is equal to pi r square times L. So it's going to be pi times 1.27 square times L. If I work in CGS, this will give me 128.7 centimeter cube, if I replace centimeter cube with meter cube, I would need a 10 to minus 6. So this would become 1.287 10 to minus 4 meter cube. Then I can calculate the magnetization, that is magnetic moment divided by volume. So I have a magnetic moment of 10,000 EMU, which is ergs per Ørsted, divided by the volume 128.7 centimeter cube. So I obtain 77.7 EMU per centimeter cube. So this is the magnetization in CGS. In CGS units. Or I can do the magnetic moment 10 ampere meter square divided by the volume 1.287 10 to minus 4 meter cube, and this will give me 77,700 ampere per meter for magnetization in SI. And you can also see that 1 EMU per centimeter cube is 1000 ampere per meter. So basically we have multiplied the magnetization in CGS with 1000. And part C, what current would have to be passed through a 100 turn solenoid of the same dimensions to give it the same magnetic moment? So what is the magnetic moment of a 100 turn solenoid? The magnetic moment of a n equals 100 turn solenoid, we can calculate it as the total current n times I times the area. So this will be 100I times pi r squared, 1.27 10 to minus 2. That was the radius squared. So I'm working in SI here because I want to keep current in amps. This gives me 0.0507 I, and that's equal to 10 ampere meter square. So I find that the current has to be 197.2 amps. Okay, so we worked with a cylindrical bar magnet that is 10 inches long, 1 inch in diameter, magnetic moment 10,000 ergs per Ørsted or EMU. The magnetic moment in SI can be found by converting the magnetization to magnetic in CGS to magnetization in SI. That is 1 EMU per centimeter cube is 1000 ampere per meter. This is a conversion we know, we have derived in the lectures. And if I multiply both sides with 1 centimeter cube, which is 10 to minus 6 meter cube, I find that 1 EMU is 10 to minus 3 ampere meter square, or I can write this as 1 ampere meter square is 1000 EMU of magnetic moment. And so if I have 10,000 EMU, that means I have 10 ampere meter square in SI. The magnetization is found by dividing magnetic moment with volume. For this I have to convert from inches to centimeters and meters, and also be careful, the given quantity is diameter, so I have to divide it by 2 to find the radius. So the volume is pi r square times L, and when I divide the magnetic moment in CGS with the volume in centimeter cube, I find 77.7. Multiplying it by 1000, I find 77,700 ampere per meter magnetization in SI. And if I have a solenoid that has 100 turns, the magnetic moment it creates would be NIA. So the core material is not magnetic. This is assuming that it's not magnetic, so the only contribution comes from the current. Then I have magnetic moment NIA, and here, because I want to keep the current in amps, here my choice is work in SI units, because I want to work with amps. It's difficult to work with current in CGS units, so I want to work with amps. So instead of using ab amps, for example, I use the SI units, and I find that the current I need would be huge, 197.2